Hey, what's up guys? It's week 3 of building my URL shortener service. Hope you all had great Christmas. Even though Kai and I have been sick AF, December in Montreal still has been so nice. We're heading out to grab some hot chocolate and enjoy snowy vibes this evening. And of course, I got another vlog for you today. Hope you like it. Also, I'm partnering with the awesome guys from TestSprite. More of them later. Alright, so last week we got our very core features for the URL shortener service done, and we even connected that to basic UI. And for this week I asked myself, should I start working on UI and make it look something closer to what I imagine it should look like, or should I blow my mind with authentication and authorization flow? And you know what, there is a weird saying, you should eat the frog first. So I guess it means we're working on the login system this time. Alright, so this means that on our to-do list is only one item, and I came up with several requirements that I would need to follow for this task. So first of all, the application must be stateless, so no freaking sessions in cookies and stuff like that. I don't want to check something in database on every single request. This is crucial. Then for now, I feel like adding only 2 ways how user can log in or register in the system. The first approach would be magic links that will be sent to user's mailbox, and after clicking on the link, they will be automatically logged in into the system. And the second one is social login. In our case, it's Google sign in. Maybe I will add GitHub login here as well later, but for now it's just a Google one. Ideally, I would add here passkeys as well to make it even less frictionless, but it sounds a bit more complicated, and overall it's a nice to have feature. So I think I'm gonna add it to my backlog for now. And right, no username and password logging, just because passwords are super fragile, annoying, and simply sucks. Additionally, username and password cannot be the only way to log into the system. There definitely should be some kind of two-factor authorization. So yeah, passwords for now are not gonna happen. Not on my watch. Building complex web applications and systems is always fun, up until the moment when you start introducing bugs in it. The solution is obviously to write tests for your backend API and frontend UI, but writing tests takes a lot of hours, sometimes even days, which drains your productivity super quickly. That's where TestSprite comes in, a real time saver. This autonomous AI testing agent automatically generates comprehensive test plans from your product requirements document and code, writes and runs end-to-end tests for both frontend and backend, debugs failures, and even suggests fixes. In benchmarks, it boosts AI-generated code pass rates from 42 to 93%. It has seamless integration through its MCP server, so you can easily plug it into your IDE and let TestSprite handle the heavy lifting in minutes. And this is exactly what we are gonna do right now with our SaaS project. Right, so the setup is extremely easy. Once logging, you need to go to Home tab, press Test locally, quick install. From here you can create your API key. Then you need to install MCP server, either in Cursor, Code, or any other IDs. So in my case, I'm gonna use anti-gravity. So I'm gonna copy that snippet. I'm gonna go to anti-gravity. I'll open MCP servers, view row config, paste the code snippet, add my API key, save and refresh. And there you have it, TestSprite is installed in anti-gravity. TestSprite suggests start testing with their simple prompt, so I'm gonna copy that and let it do its work. Alright, so we are being redirected to the configuration page. So in my case, I want to test frontend for URL shortener project. And here we need to provide product-specific documentation. If you don't have one, that's okay, you can just ask Gemini or ChatGPT or Cloud Code to generate one based on your code base. And this is exactly what I did. So this is what Gemini generated for me, and I'm gonna drop it here. Continue. Alright, so it completed testing, and we can see that it created 10 test cases, and we can check the outcome of each individual test on the dashboard. And for this test, only 5 out of 10 succeeded. So let's say I'm gonna choose edit a short URL and update its long URL and title. We can see even screen capture for this test run, and it seems it caught the exact same issue that we got last week, where I couldn't update the short URL because the API wasn't properly mapped. Honestly, I was blown away by developer experience and value TestSprite brings. Try TestSprite absolutely for free. Their starter plan gives you 400 credits at no cost for the first month. You can find the link in the description. And now back to our video. Okay, and the final point on my requirements list, my application security must be JWT based. Meaning my application must be able to issue short-lived tokens, long-lived refresh tokens, and what also crucial about that, my application must be able to verify those tokens at runtime. So now it's time to put all this flow on the board. So I imagine the login screen should look something like this. There should be two options, either login with Magic Links or with Google Sign-In. And here is how Spring handles that by default. So for Magic Links, it generates one-time token, and you would need to be responsible for sending that one-time token to user. And in case of Google Sign-In, the user is being redirected to Google consent screen, which shows what resources the application is currently requesting for. And in case of the Magic Links, user should see a mail something like this with the button sign in, and the one-time token that Spring generates should be set in this button. So right after user clicks on the sign in button, they are being redirected to the application page where they need to enter their one-time token, or the token will be preset automatically. And after clicking on the sign in, Spring handles one-time token flow, generates session for the user, and store that either in memory or Redis or database or any ways that you prefer. And we have a similar flow for Google sign in. So after clicking continue, Spring communicates with Google, makes sure that the credentials that are redirected by Google are valid, and then it goes to the same route where it generates and stores the session. Right after the session is generated, Spring sets JSession cookie with the session ID in the response headers and returns that to the browser, where browser's responsibility to save the session cookie in the browser storage. And from there on, any API requests that are done by the browser should contain that session cookie in HTTP headers. And when that call is made to the backend, Spring does the check for the session in any storage that you have. So if the session exists, it allows to execute business logic. If it doesn't exist, Spring returns for unauthorized error. And what's interesting is that by default, the OTT flow assumes that user already exists in database. And in case of Auth 2 flow, which is Google sign-in, it doesn't create a user, it doesn't check the user in database, it operates on behalf of Auth 2 user. So all of this is definitely great to have out of the box, but it's not ideal for my application, and that's why I adjusted a bit the flow. So if we go to the flow that I created, the starting point is just the same as the default one. Then we have the same screens, and the main difference is the way I handle the final step for both of these flows. So instead of generating session and storing that in the storage, I want to generate JWT access and refresh token. tokens. Then I want to map those tokens to one-time authorization code, and eventually I want to store both of those in cache with the short TTL. Then right after that, the authorization code should be redirected to the browser, where browser received the code and immediately send the request to exchange the code with the JWT token pair. So when my backend received that request, it checks whether authentication code exists in cache. If no, it returns 4 or 1, similarly that we saw in case of storing sessions. And if it exists, server should immediately invalidate code from cache and return JWT token pair in response. And then when the client each time makes a request, it should include access token in headers. And the main benefit of having JWT token headers instead of session ID is there won't be any database lookup, and JWT token will be validated at runtime. Server will be able to validate expiry, role, and scope for the current user. If the token is valid, it throws either for 1 or for 3. For 1 is basically if the token is not valid, and for 3 is when the user tries to access resources that they shouldn't be accessing. And when the token is valid, obviously we're allowed to execute the business logic. So yeah, if we zoom out, we can definitely see that the second flow is slightly more complicated, but it has more benefits to the previous one. So the main benefit for using JWT tokens versus sessions is that JWTs are self-contained. They basically carry all the information about the user for the verification, and the server does not need to do database lookup on every request, which give us this statelessness. It also provides us better scalability, and it reduces database load. With that said, JWTs has their own trade-offs as well, and probably the main one is that from the moment the token is issued, it is harder to revoke that, but I think it can be easily mitigated by reducing token expiration. Honestly, I don't really like to deal with security and expect it should take at least 2 days to implement all this. Alright, so the implementation took 3 days instead of 2, and yeah, it seems that I'm kinda bad at estimates, but anyways, let's break it down. So what I like about Spring Security is that right after you add that to your project, it has lockdown policy. This basically tells the application, if I didn't explicitly say this public, block it. And my first default configuration for Spring Security was to allow all the actuator endpoints that exposes health check endpoints and some useful information through the API. And also I allowed all the error endpoints, and then any other requests should be denied. And since our application supports 2 ways how user can log into the system, I have dedicated configuration for magic links, and in Spring Security it called one-time token, and the same for Google Auth 2. And let's start with this one because it seems a bit easier to digest. So first of all, to make all this work, we need to generate our Google credentials on Google Dashboard. And for this one, there is nothing complicated. So we go to API services, then I go to consent screen, enter my app name, support email. I would like to choose external audience to test my application, so I could add any emails here for my login testing. Okay, my contact information, agree, continue, create. Okay, now I go to data access, add scopes, and here I choose first 3 and then create Auth 2 client. So here we choose web application, you can choose any name you want. And as for authorized URIs, you need to choose the one that will be handling Google code that will be returned to your application. In my case, it's the default path that defined by Spring. So I'm gonna use that. And here we go. So we copy this client ID and client secret into our application. And then right after user went through the consent screen, the Auth 2 success handler is being triggered. And what it does, it basically gets email of the user from the information that Google returns. Then I'm trying to find the user in database. If it doesn't exist, I create the user. And right after that goes the flow that I explained earlier on our diagram. I create JWT JWT token pair and store it in cache along with the auto-generated authentication code that will be mapped to this exact token pair. And here is how it looks like. So here again I'm using Cafe and Cache. I generate the code and I put the token pair in there. And expiration for this cache entry is 30 seconds. I explicitly set TTL to super short period, so there would be way less chances to intercept the code and to execute it on someone else's behalf. And what I do then is send this authorization code to my front end, where it immediately calls exchange endpoint, where it can exchange the authorization code with the actual tokens. And here what I have in my exchange controller, so it's super simple. Step 1 is to find the token pair by code in the cache. If it doesn't exist or if it expired, the application would return for one unauthorized error. But if token is there, I remove it from cache and return the token pair, which are my two JWT tokens for two different purposes. I'm gonna get back to this a bit later, and now let's check our magic link flow. So in this security configuration, I disable default Spring page for submitting one-time tokens because I don't need that. Then I define one-time token service. By default, Spring uses in-memory one-time token service that by its name creates and stores all the generated tokens in memory, which is not ideal, but fortunately there is another Spring implementation which is GDBC one, and this one stores all the generated tokens in database. Then another thing that I needed to customize is one-time token authentication provider. This component is basically triggered when client sends one-time token to the backend and it tries to consume the token. If the token is consumed successfully, it tries to load the user by username. And since I don't have any other registration ways in my application to create a user, I need to have some kind of user auto-provisioning mechanism. And this is exactly why I created auto-provisioning user detail service. So similarly to Google sign-in flow, it tries to load the user from database, and if the user is not there, I simply create a new one. And I actually skip one important part in this flow, which is one-time token sender. So once the token is generated internally and stored in database, the end goal of this component would be to send the magic link email to the user. However, since currently I don't have any integrations with any email providers, I simply output the magic link in my logs. Alright, so once the token is generated and sent to the user, we need to handle the magic link login button in user's mailbox. And this is exactly a responsibility of this success handler. So I would say it does more or less the same as Google sign-in. It gets the mail from the token, then it fetches the user, generates JWT token pair, and send the same redirect to my friend to exchange the code with the tokens. Alright, now let's explore our JWT components. The first one is that is responsible for token generation, and there is nothing complicated here. I either generate access token or refresh token, and they are different only by their scope and expiration. For access token, I choose to have TTL of 1 hour, and for refresh token, it's 30 days. Then I have business scope for access token and refresh token scope for refresh tokens. Then I compose the payload of the token. I set when the token is issued, when it expires at. I set user ID as a subject, so it would be easier to fetch user ID in my controllers. Then I set user role and encode that with my pre-configured encoder. And usually when I watch some guides on YouTube or read some articles about how to implement JWT flow in Spring Boot, in most cases I see people implement once per request filter. For me personally, this looks terrifying, and I don't know why people still use this approach, because there is a way better way to achieve the same but with the built-in Spring mechanisms. So all you need to do is define your JWT encoder and decoder, and all the rest will be taken care of by Spring. And with all this security configuration, my short link controller now looks like this. And let's say the request comes in and Spring validates whether the token is valid, so it's not expired, it is not being forged, the signature is correct. Then I can create annotations like this, which I can put in my controller class. So even if I have other tokens and they are valid, they won't be allowed to access resources in this controller. The application should return forbidden HTTP status. And when I was telling that I can easily fetch user ID from the token payload, I implemented this annotation, which provides exactly this information. And to achieve that, I needed obviously to create an annotation which will get user ID from the JWT authentication principle. Alright, enough talking, it's demo time. I'm gonna start my backend application. Then I started my frontend application. And for this one, I asked Gemini to create a simple login page so I could handle all these redirects and token exchanges. So first of all, I'm gonna try to create a magic link. Alright, send magic link, and here you have it. So this URL will be eventually hidden behind a button in the user's mailbox. So if I press on that, so the code that you can see here was sent to my backend, and in response it returned the token pair. And what I like about JWT tokens that you can easily debug the content of it. I'm gonna paste my token here, and here you can see the row that I issue for this token, the scope, and also two dates when it was issued and when it was expired, along with the user ID. And if we check our database, I have auto provisioned the user for this email, and as a proof that my endpoints are protected right now, I'm gonna try to create short link without any token passed in the headers. So if I make a request, I get for one unauthorized. But if I get this token, put it in the headers, and make a request again, as you can see, the short URL was created successfully. And if we try to check the refresh token payload, the row is also user, but the scope is different. And when I try this token for creating the short URL, I'm receiving 403 forbidden error, which is exactly what we're expecting. So this means that my backend recognized the user, but the endpoint they're accessing is basically forbidden for them. All right, so this works. And now let's test our Google sign-in. Here I have my two Google accounts. I'm gonna select this one. Here is the Google consent screen that we configured on Google Cloud dashboard. And if I press continue, I have user auto provisioned for this Google account as well. And we have our token pair that the browser will be storing somewhere more safe than here. All right, so that's all I have for now. And I see you guys in the next one.